All right, so today we are going to work with solving equations. So our goal today, make sure to write our goal up at the top of our paper, is to solve equations. So the first thing we're going to talk about are the differences between expressions and equations. So the first description we're going to talk about is what is the difference. So an expression, it's going to have at least two numbers. So it's going to have a minimum of two numbers and some kind of operation between them. So, and at least one operation. And we worked with expressions last week. And what did we do with them? We simplified them. So we did the operations, we got it down to a single number. So that's what we did with them. We would simplify them. Okay. What did we use to simplify them? Remember that phrase? Anyone? PEMDAS, yeah. So which are the order of operations? So a sample problem, something might say to simplify. And then maybe it gave us an absolute value. Maybe it was 2 times 6 minus 4 times 7. And you got to work from the inside out. And 2 times 6 is 12. Minus 4 times 7 is 28. We have to subtract there. 12 minus 28 is negative 16. And the absolute value of negative 16, remember the absolute value is how far away is negative 16 from 0, and that distance is always positive. So our final answer is just positive 16. So that would be an example of, or a sample problem of when we had to take an expression and simplify it. So today we're going to start talking about equations. And this is a math statement. It's going to have an equal sign. So really what you have is an expression on the left is equal to an expression on the right. And what are we asked to do with equations? We are asked to solve them. And typically it will say like solve for X or solve for Y, or it'll tell you which variable to solve for. Now, while we're solving these, whatever you do to one side, you have to do to the other, okay? And what these are called are properties of equality. And we'll write down an example of what one will look like. It'll say solve for X. And maybe you're given that 2X minus 3 equals 15. So the properties of equality tell you whatever you do to one side, you have to do to the other. So in this case, I'm trying to get X alone. Right now, you're subtracting 3 from it. So I'm going to add 3 to both sides. Because whatever I do to one side, I have to do to the other. And I wanted to get rid of that other term because the term with X in it, I want to get that alone. So now what I have is 2X equals 18. And x is still being multiplied by 2, so in order to undo multiplication, we are going to use division. So we are going to divide both sides by 2, and you're going to get that x is 9. So that's how we would solve an equation. So we have 3 example problems here that we're going to do together, and then I'll let you guys try a couple on your own. So the first one is 5x minus 3 is equal to negative 33. Can anyone tell me what the very first thing I'm going to do with that problem should be? Add what? Exactly. Add 3 on both sides. When you add 3 on both sides, the minusing 3 and the adding 3, those are going to go away on the left, which gives us our 5x term all by itself, which is exactly what we were aiming for. So we have 5x equals negative 33 plus 3 is going to be negative 30. All right. And then what do we do next? Divide by 5 on both sides. Very good. So x is being multiplied by 5, so to undo multiplication, you're going to divide. So divide both sides by 5. Your 5's go away on the left because 5 over 5 is just 1. So we have 1x equals, what is negative 30 divided by, negative divided by a positive is a negative number. 30 divided by 5 is 6. So x is negative 6 is our final answer. Now we should plug it back in and make sure that it works. So plug it back into the very top. So 5 times negative 6 minus 3 is negative 33. And the right side says equals negative 33. So it looks like I did it right. That's how you would check your answer. You can plug it back in and make sure it works. If you have a phone, let me show you. I have a bunch of calculator apps on here. Right here, calculator. And there's this one, it's called Calculate 84. And if you click on it, skip for now, I don't want to log in. Skip anyways. There we go. It actually looks just like a graphing calculator. You can see it has literally all the same buttons as this graphing calculator right here. So that's pretty cool. Some of the features are locked unless you purchase them. So you can't do everything you can do with the graphing calculator, but you can do all the basic stuff that we need to do in this class. So pretty cool that you guys can have a graphing calculator right on your phone, as long as you guys have a phone. Your phone's like $1,000, so you'd think that it should have the same features as your $100 calculator, right? So, all right, so let's try this next one. This next one's a little bit different because A, actually, we're solving for A, and it shows up twice, okay? So that's on both sides. So what we're going to have to do is we're going to have to get A to one side. It does not matter which side you move it to. So you could either subtract 5A on both sides or subtract 11A on both sides. It's not going to matter. Some people always like to move it to the left because in the end they like their equation or their variable written on the left. That is totally fine if you want to go that route. Or you can just rewrite it in the end, or you don't have to. It doesn't matter. I like to deal with positive numbers, so I would choose to subtract the smaller one. But that's just because I try to make it so that it's always positive. So negative 9 equals 11A minus 5A is going to be 6A. And that's why we practiced combining like terms last week. That's all you're doing right here. You still have that plus 3. Okay. Now your 6A, you only have one term with an A in it, which is on your right. So you have to get rid of that other term that's on the right. So we're going to subtract 3 on both sides. Your 3's are going to go away. And we're going to have negative 12 is equal to 6A. And divide both sides then by 6 so that we get A alone. And negative 12 divided by 6 is negative 2. So A is negative 2. All right, so this next one, what's different about this one? What's this last one have? It has parentheses. So if you use the distributive property, you can actually distribute that negative 3 to both terms. And think about this as plus negative 4. And distribute that to both terms. And then what we can do is we'll get rid of all the parentheses because if we distribute them, we don't have to write it with the parentheses anymore. We'll have negative 6m minus 9 minus 12m plus 24 equals 15. And now we get to combine like terms. So you can simplify the expression on the left side. Okay, so we have negative 6m and negative 12m. These are like terms. And then the negative 9 and 24 are going to be like terms. Negative 18m plus 15 equals 15. And then again, we're just trying to get that m term alone. So now you're adding 15 to it, so we need to subtract 15 on both sides. But what happens in this case, on the right side, what do we have left? What do we write if we have nothing? What number is nothing? 0. Okay. You still have to write it. You still have something over there. It's just that you have 0 over there. Okay, so don't forget that you have to write it. And then from here, negative 18 times what number gets you 0? So in order to undo multiplication, you are going to divide. And you'll get that m is, what's 0 divided by negative 18? 0. Okay, some people get confused when they get something like that because there is a rule in math about division and with 0. But you can take 0 and divide that by negative 18 and your answer is 0. Okay, does anyone know that rule that I'm talking about where you get an error? What is it? It's not just 0 divided by 0. It's if we did it the other way around. If we took 18 divided by 0. Whenever you divide by 0, you'll get an error. It's not possible. So when you divide by 0, you're going to get an error because you're not allowed to divide by 0. Okay? So that's going to be an error. But you can do 0 divided by a number, and that sometimes confuses people because they can't remember, well, which one is 0 not allowed to be? Is it not allowed to be on the top of the fraction or on the bottom of the fraction? And it's the bottom. And if you're ever not sure, type it into your calculator because a fraction is just a division sign. So try it. What's 0 divided by negative 18? Don't just assume, always double check. Okay? All right, so there are 3 more problems. I'll walk around and help you guys out with those, but I want you guys to try those on your own. Okie doke? So let's try those. Okay, so what we should have gotten here was, for A, you should get y equals negative 4. Raise your hand if you got that. Pretty good chunk. Do you want me to go through that one? Should we go through it? So you're going to add 8 on both sides. Okay, you've got to get the negative 6y term by itself, so you're going to add 8 to both sides. Then you'll divide by negative 6 on both sides. And then you'll have y alone. Okay? For part B, who got negative 18 fifths? Anyone, anyone? Did anyone get 36 over negative 10? Okay, so that's actually correct. You just did not simplify, you reduced that fraction. Okay, so let's go through this one since not many people got this one. The first thing that we're going to do, what was the first thing you guys did? You added 4x to both sides? Okay, so we'll do that. I'm asking you because I want to see, so that way you guys have a better chance to see where you guys went wrong. So add the 4x on both sides. Negative 15 equals 10x plus 21. And then what'd you guys do? Subtract the 21. All right, so on the right side, we're going to have just the 10x. Negative 15 and negative 21. So that's a 6. Negative 36. And divide by 10 on both sides. Okay, so x is alone. I just wrote it on the left. Negative 36 over 10. Both of those, I can see that they're even numbers, so I know they're at least divisible by 2. So half of the 36 is 18, and half of 10 is 5. And when I get it there are no numbers that go in both 18 and 5. So I know it is the most reduced version of that fraction. Did we figure out where we went wrong? Good. This is what we're supposed to do here, practice. All right, how many got c equals 8 on this one? And the last one here. Okay, a chunk of you guys. Should we go through this one too? Once you distribute the 5, and remember, think about that as plus a negative 3, so that you can distribute that negative sign. We should get 5c minus 40 minus 6c minus 36 equals the negative 84. How does that look so far? Raise your hand if you did that part right by distributing. Okay, so maybe it was that negative sign here that we forgot. All right, so once we're there, then we can combine like terms. So 5c and negative 6c is minus c. Negative 1, right? Negative 1c. Negative 40 and negative 36 is going to be negative 76 is equal to negative 84. Add the 76 on both sides. Negative c will be negative 8. And then it doesn't matter at this point, but you can multiply by negative 1, or you could divide by negative 1, whichever one you want, because it's not going to change the value, it's just going to change the sign if we divide or multiply by a negative. So we get c equals 8. And that's that. How do we feel about solving equations? Give me a 1 through 5. 5, I'm doing awesome. I can handle this on my own. Down to a 1, I've never seen any problems like this in my life. Or maybe it's Monday and I'm still sleeping. Yeah. All right, let's flip it over. Now we're going to practice when we have to solve an equation, but it's for a variable. So in these, we only have variables. This first one, it's how to find the, usually that's volume is equal to length times width times height, but a lot of these are equations that you might see from other classes, like that one would have been from geometry if that was a V there. This one down here, PV equals nRT, that's a chemistry equation. So these, sometimes you'll see equations, they come up in your science classes where they actually have meaning to them. But in math, we learn how to manipulate those equations so that when you're in your other classes, you actually know how to move things around there. So let's say we needed to actually figure out what our H was, and we had to solve for H like 100 times. We wouldn't want to have to plug it into this equation and solve every single time. Instead, we would want an equation that's listed as H equals da 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 da, and then we could plug it in, right? So we're going to manipulate this equation to make it H equals instead of A equals. So to get H alone, what is happening to this H right now? What's going on to that H? What operation? It's being multiplied by what other two variables? I think that's supposed to be an L, but yeah, L and W. So how do you undo multiplication? Division. So what we're going to do is we're going to divide both sides by the L and the W. And then on the right side, our L goes away, our W goes away, and what we're left with is H. Now, on the left side, we're going to write it exactly how it looks. A over L times W. L and W are both going to be in the denominator. And then just because I want my final answer written nice, I'm going to write H equals A over LW. Because I solved for H, so I like it on the right. Now if we had to solve for H like 100 times, we can easily just type it into that formula, and we'll have H. We don't have to plug it in here and then solve for H every single time, because we have a new equation where H is what we're finding. Do we kind of see the purpose of this? So, the next one, we have to solve for X, okay? Now the problem is that X is in two different spots here. So the first thing I'm going to do is I'm going to get rid of that other term that's on the side and just leave the two terms that have X in it. So I'm going to add 15 on both sides. And I'm going to get AX plus BX is equal to 15. Okay, and then I'm going to take and I'm going to do a little side note here. Okay, something that I want you guys to think about. And you don't have to write this down, but it's just something I want you guys to visualize. If I asked you what 7x plus 2x is, what is it? What's 7x plus 2x? 9x. How do you get 9x? You're adding 7 and 2, so you're thinking about it like this. Right? So we're going to have the same thing here, but what would we have to add together? You have something x and something x, but what are we going to have to add together here? A and b. So the way that you can write this is a plus b x. Does that kind of make sense? And it's kind of like you undistributed it. Like that x was being distributed to the a and the b, you undid that. Okay, that's what we call factoring. You guys did that back in Algebra 1. It doesn't matter if you write it on the right or the left because the order of multiplication doesn't matter. So it doesn't matter if you multiply by x on the right or the left here. But that's what the left side's going to look like, and then that's still going to equal 15. Okay? Now the reason why we had to do that was because we couldn't get x alone if it was in two different spots here. So we had to get it in one spot, and now that it is in one spot, how do we get x by itself? What is happening with x right now? It's being multiplied, right? So undo multiplication by division, and we're just going to divide by those parentheses. Now your parentheses go away on the left, and we're left with x equals 15 over a plus b. All right, we're ready for the last one? Last one says we have to solve for b2. Okay? You have two different types of b variables here. You have b1 and b2. They are not the same. Okay, so you have to treat them as if like one was x and one was y. They are two completely separate variables because of those little numbers next to them. Okay? Now the first thing I see here that I'm not a very big fan of is that has a fraction in it. And I like to get rid of the fraction, so I'm going to multiply both sides by 2. If you want to get rid of a fraction, it's just division. So right now it's being divided by 2, so if you multiply both sides by 2, the 2 times 1/2 is 1, so you got rid of it on that side. And on the left side, we're going to have 2a equals h times the set of parentheses still. I still want to get b2 by itself, which is stuck inside these parentheses. So I'm going to try to get the parentheses alone so I no longer need the parentheses there anymore. The parentheses right now are being multiplied by h. So I'm going to divide both sides by h. So the h's go away. On the left I have 2a over h equals just the parentheses now. So I no longer need those parentheses. b1 plus b2. Now I'm trying to get b2 by itself. So what do I do to get b2 alone? Subtract that b1. Yep, right now we're adding b1 to it. Now this is going to look a little funny over here if it was written like that. So when I rewrite this, I'm just going to write it as two separate terms. You can't subtract b1 from this fraction, so I need to write it 2a over h minus b1. And that would be your final answer. Okay, because those are not like terms, so they're two separate terms there. There are 3 problems for you to try, so go ahead and try those. What are we going to do to get the 2w term by itself? What's happening to it right now? It's being added to 2l, right? So how do you undo addition? Subtraction. So we're going to have to subtract 2l on both sides. P minus 2l are not like terms. So when we write this, we're going to have to write it P minus 2l is equal to 2w. We're going to have to write it as two separate terms. Okay? Now, what's happening to the w? All right, what's still happening to the w? What are we going to have to do next? It's being multiplied by 2, right? So how do you undo multiply by 2? Divide by 2. If we divide both sides by 2, you can write this two separate ways. You can divide each term by 2 or divide the whole thing by 2. I like to do each term because sometimes you forget about things if you write it all over 2. When you do that, this is still p over 2. There's nothing you can do with it. But 2 over 2 is 1, so this is actually minus l. And over here, you're going to end up with just w, so then I wrote it backwards. Do we see where we went wrong? If you wrote this so that it was p minus 2l all over 2, did anyone write it like that? If you wrote it like, okay, so that's actually correct then. You don't have to mark yours wrong. Okay, that's actually going to be correct. How about this one? Who got n equals PV over RT? Good, a couple people. Awesome. So what did you guys do? You were trying to get n by itself, so what did you have to do to both sides? It's being multiplied, so what did you divide on both sides? RT. So the r's cancel, the t's cancel. You'll be left with just n. From there, that's your answer. That's all you have to do there. All right. Part C. We are trying to get a by itself, and it's inside those parentheses. Okay, so here you have your first term, and then there's that second term. You have to get rid of that other term first. So we're going to add d to both sides. So we'll have f plus d over there. Next, since we're trying to get the a, which is inside those parentheses alone, try to get the parentheses alone. What's happening to the parentheses right now? They're being multiplied by c. So we divide by c on both sides. And I'm going to divide each term by c over here. So my c's go away there. I'm going to have a plus b is equal to f over c plus d over c. And then what comes next? We're trying to get a alone, and it's being added to b. So subtract b on both sides. And that's going to be a separate term. If you wrote it underneath, it doesn't matter because eventually you're going to have to write it off to the right because it is a whole separate term. And that's how we get that final answer. Okay. We have a couple different examples where we have to write an equation to solve a problem, a story problem. So it says write an equation that illustrates each situation and then solve it. All right, so this first one says a dog kennel owner has 100 feet of fencing to enclose a rectangular dog run. I like to draw a diagram. Here's my diagram of my rectangular dog run. She wants it to be 5 times longer, or 5 times as long as it is wide. So if this is the width, and the length has to be 5 times longer, how would you figure out what the length would be? 5 what? Times W, right? 5 times longer than the width. You just do 5 times the width to figure out that length. What would this side be? What would this side over here be? W? What would the top part be? 5W? Right? Now when we add up around the outside, the perimeter would be W plus 5W plus W plus 5W. That's going to equal a total of how much fencing do we have total to go all the way around? No, how much fencing do we have? 100 feet of fencing, right? So when I add up around the outside, it was going to equal 100 because that's how much fencing I have to go all the way around. So now we have to figure out how long should each side be. So we have to solve for W. We'll at least have the short sides, and then from that we'll be able to figure out the long sides. So on this side, I'm going to simplify it. I'm going to simplify this expression because I have a bunch of like terms there. How many W's do I have on the left? More than 2 W's. More than 4 W's. I have 1 W, 5 W's, 1 W, 5 W's. Not 13, 12. 12 W equals 100. So then we solve it. How do you get W alone? Divide both sides by 12. We'll get that W is, what do we get? What's 100 over 12? 50 over 6, 25 over 3, 25 thirds. Or, since we're dealing with length, it's 8 1/3. So 8 1/3. So that's 8 feet and 1/3 of a foot. 1/3 of a foot, though, if a foot is 12 inches, what would 1/3 of that be? 4 inches, right? If you split a foot into 3, you'd have 4 inches, 4 inches, 4 inches. So this is 8 foot, 4 inches. So this side is 8 foot, 4 inches. This side is 8 foot, 4 inches. And now we just have to figure out how long are those long sides going to be. Well, if that's 8 foot, 4 inches, how are you going to figure out what the 5 times W is? Times it by 5. So there was the 8 1/3. Times that by 5. 41 2/3. And 2/3 would be 8 inches. So 41 feet, 8 inches. All right. It says the lengths of sides of a triangle are in the ratio of 3, 4, 5. So if I draw a triangle here, one of them is 3x, the other is 4x, the other is 5x. And it says the perimeter is 18 inches. So if I add up around the outside, 3x plus 4x plus 5x, I'm going to get 18. Find the length of its sides. Okay, we'll simplify the left side. What is 3x plus 4x plus 5x? 12x equals 18. Okay, divide both sides by 12 to get x alone. X is going to be, reduce that fraction. So that's the same as 9 over 6. Divide both those by 3, 3 over 2. So x is going to be 3/2. When we're talking about lengths, especially if it's going to be inches, we can write it as a decimal. That would be okay. So 3 times 3/2. 4.5 inches. 4 times 3/2 is 6 inches. 5 times 3/2, 7.5 inches. And there you found the 3 sides of the triangle. The last one says, for Nina's illness, her doctor gave her a prescription, and there's 28 pills in that prescription. And the doctor says she has to take 4 pills on the first day, and then after that first day, she just has to take 2 each day. So, until her prescription runs out. How many days does she take 2 pills? So, how many days is what we're trying to figure out. So, if x is days, she's taking 2 pills per day, times x amount of days, plus what did she take initially? 4. And how many does she have in total? 28, so it equals 28. And now we can figure out what x is, and x represents her number of days that she takes the 2 pills. So the first thing you're going to do is what? Subtract the 4. So I'll let you guys figure this one out. What did we get? How many days? 1 day? 12 days? Raise your hand if you got 12 days. Anyone get anything different? No? I also got 12 days. So, that is your notes. The next page is your assignment. So if you flip over in your packet, Unit 1, Lesson 3 is 1.3 assignment. Okay? So this is what you're working on, the front and the back of it. And you have the rest of the time to do so.